we get into the show, though, I have to say a couple of things about safety. As you can see, we're kind of decked out in safety gear, and this is in part because many of the chemicals that we're going to be handling today could be potentially hazardous if they came in contact to your skin. So, for that reason, we want to make sure that we are being safe and that you are being safe as well. So, to help us out with safety during the show, we're going to please ask that you remain seated during the show. Please, if you do need to get up, please go directly to the exits behind you. Do take a moment to look around, just like you're in an airplane or a movie theater, and familiarize yourself with the locations of our exits, so that you know where you need to go in case there is an emergency. However, at the end of the show, when you're exiting, please do not use this exit over here. This is where our chemicals are. There are potential hazards back there. I don't want anyone accidentally coming into contact with something. You can use any of the other 3 exits at the end of the show. A couple of times during the show, there are going to be some bright lights and loud noises. We will give you a warning when those are coming. We will tell you to cover your ears, and when we tell you to cover your ears, please do cover your ears. There are going to be some loud noises in an enclosed space, so that you're going to know when those are coming. If you have young children, give them a warning, help them make sure that their ears are covered as well. All right, well, I think that's about it for safety. So if are you all ready for us to get started? Right. So yeah, for a long time we've been running this show, and people refer to this as the chemistry magic show, when really, like, all of the magic here is chemistry. But I'm not going to be the one telling you about it today. I'm going to hand things over to some of our UC Davis undergraduate students and let them tell you what's going on today.
Thank you, Dr. Crabtree. Oh wait, we get extra credit for this, right? Hi everyone, I'm Aaron and I'm an applied chemistry major here at UC Davis.
Hi, and I'm Lauren. I'm a forensics chemistry major here at Davis.
Hi, and I'm the magnificent, dashing, illustrious, talented, brilliant, magical Quark, ready to dazzle you with a once-in-a-lifetime chance of a chem magic show.
Dude, so much more than enough. Let us dazzle them with a one-of-a-kind chemistry magic show, right? Yeah?
Aren't you going to introduce your little friend, Quack?
She's not that relevant. She's my apprentice. As you all know, magic is hard. I'm old. I need to retire soon. So, yeah, she's here to learn from the job and take over for me.
Hi everyone, I'm Anushka. This job was the first one I saw on Indeed. So very excited to end my unemployment with Quad.
So, in just a moment here, our lovely assistants in the back hallway will be taking out a large series of vials on the table there. They're very fun and fancy. So our assistants are going to add a few drops of base to them right now.
The magic potion, please.
Sure, the magic potion.
Magic.
Yeah, magic, totally. So this magic potion contains indicators, which are molecules that change color when a hydrogen is added or removed. So this basic potion removes hydrogen from the indicators and causes them to do these wonderful color changes.
Love a bunch of magical colors. Wrangle, everybody!
Are you sure it's magic, Quad? Lauren's explanation makes a lot of sense.
Of course it's magic. Magic is science come to life. Now, what did I say about questioning me? Do you not want to get paid for today?
Hey, don't be so hard on your apprentice, but Quack is right. Chemical reactions can be quite magical. Now let's see what would happen if we added the hydrogen back. So right now, our assistant is adding acid to the vials. So we're losing all of our colors. Oh no!
But my colors, Why are you taking them away?
Worry not.
Worry not.
This is what's expected. So when we added the base, we stripped the solutions of their hydrogen, and by adding the acid, we're adding the hydrogens back in, which returns their vials to their original state.
Cool,
right? It'll be fine.
What colors is that? Get me a new badge.
No need for that. There's still plenty more magic we gotta show off.
And what?
Speaking of magic, do you remember that one scene when Aladdin rubs the magic lamp and the genie appears? What if we summon our very own genie?
Okay, I see where you're going with this. Who wants to see a genie? Yeah? Let's summon your very own genie then.
This flask contains hydrogen peroxide.
The angry potion.
And our assistant will now add the potassium
The
iodide.
magical powder. Apprentice? I hope you're writing all this down and not just standing there looking pretty. You know, I'm checking after this.
Are you going to make her submit a post lab as well?
That's a fantastic idea. Thank you for that. I want this in ACS. Abstract, citation, all the works. By today. End of show.
Can I get a bonus for that?
Not at all.
Maybe seeing the rest of this experience will cheer you up, Anushka. Add the magical powder.
I don't pay them either, so give them a second.
Wait for it.
Aladdin is being stingy. I don't understand what's the deal with him. He already got his 3 wishes. Where's mine?
The genie's just on vacation. Give him the time to wake up. Come on, no one wants to get up this early in the morning.
Do I need to come over there and rub it for you?
Maybe not. Let him rest.
Okay.
I don't know whether or not he's actually going to show up for us today. He might just be too tired.
Okay. Well, sorry folks, no cheating. He's on vacation, probably in the Bahamas. But, you know, we can still explain the magic and science behind it. One of you care to?
Sure. So normally, the hydrogen peroxide slowly decomposes to water and oxygen gas. But this happens slower than lab reports are graded. So we need to speed it up a little, or else we'll be here for a hot minute. Because of the steam. The magic powder, or potassium iodide, speeds up the reaction and releases steam. We call potassium iodide a catalyst for this reason.
I'm kind of really bummed out that we didn't have a genie. I wanted to make my 3 wishes. So I actually have this really nagging coding project I have to do for next week. I really wish I would just go away.
Say no more.
Yeah. But anyways, let's get a move on, yeah? This next trick is one of my favorite. It involves something hygienic, something that you all should be very well accustomed to, some more than others. It's toothpaste. Your mom's gonna nag you about using it, so is your dad. It's gonna make your orange juice taste funny. So, you know, toothpaste.
Importantly, this is not real toothpaste, so please, please, please never put this in your mouth. That'd just be a really bad time.
Now presenting our lovely assistant, Kevin, who will transmogrify. Claps for Kevin, who will transmogrify just a few drops of this angry potion into a towering tower of toothpaste. Double toilet. No, that's not appropriate.
Sorry, you were taking too long.
Unbelievable. I'm the magician here. God.
Too bad. So, just like with our last experiment, we are again breaking down hydrogen peroxide with a catalyst, what Quack calls the magic powder. And in this case, we added a little bit of dish soap and food coloring for some fun pizzazz.
No, well, the color was my idea, so don't give her any credit for that. Now, you guys know what's even cooler than all this toothpaste shenanigans and bubbles? Fire bubbles. Yeah? Set things on fire?
I love fire.
Yeah, calm down, arsonist.
Okay. Right now, our assistants are putting out some soapy water and a tank of gas. And now they are going to gently make bubbles by flowing the gas through the liquid.
So I'm kind of having second doubts about this job. So I'm exploring other options. I'm gonna try out my stand-up on you guys while we wait. So why did the methane molecule break up with the hydrogen? Does anyone have guesses? Do you have guesses? Because, wait, do you guys have guesses?
I don't know.
Because it was tired of all the gaslighting. Something that happens to me every day on this job.
Any more?
I don't pay you to make all these jokes. I don't pay you.
Don't pay her.
But yeah, you're done, right? You're done? We can proceed? I give you fire bubbles!
So those bubbles were full of... Hi. So those bubbles were full of combustible hydrocarbons called methane. Did you guys know methane is the main component of natural gases used to heat our houses?
And did you know that you alone are eating up all the methane in our homes because you love to take long hot showers?
I do, and that's why I smell so good. I take my time to look presentable and clean. Thank you very much.
So for this reaction, methane burns by reacting with oxygen in the air in a process known as combustion. Combustion produces heat, light, and sometimes sound. The fire burns only as long as there's methane present. So when it runs out of fuel, the fire goes out.
All this sciencey talk. Let me translate that to some magic terms for you. The fire that doth burn be eternal for as long as manna doth flows, and the arcane radiance and luminosity shall accompany it as it draws its final breath.
Dude, what did you just say?
I think I got this. He said, the eternal doth fire flows, and the resonance arcane radiance draws its fire breath. Resonance. Right?
Maybe you should look for other jobs. More bubbles, please.
Anyway, so do any of you have any cash on you?
I only have one bill left. Like, you can't make me do this.
I didn't ask, hand them the cash, I'm firing you.
You'll get paid at the end of this, at least by us. Don't worry. Anyways, Erin and I actually came up with this trick that we wanted to try with the fire.
That was my only bill.
Don't worry.
What is happening?
Just trust the process.
You got any more jokes, friends? No? Okay. I kind of like the comedy show, I'm not gonna lie.
You should really practice more jokes. You might do stand-up comedy after this. So, you ready?
You good?
Light the bubbles! Don't worry, it was only $1. We can just burn it. It's fine?
Your bill is perfectly fine.
So, we soaked your bill with water first, which protected it from burning. Even though you saw the flames, it takes a lot more energy to boil off the water than it does to burn the paper. So your bill was fine the entire time.
Now you can go buy your Starbucks. I know how much you love Starbucks. Now, since you got your money back, you won't need me to pay. I hope you guys are paying, right?
Sure, an extra credit, supposedly. Anyways, for our next experiment, we'll need all of you to cover your ears when we ask, or we can't proceed with the show. We always make safety our #1 priority in chemistry.
Cover your ears, folks. Cover them. Better not see anyone without ears covered. Ignite the balloon! What was that about? Is this a joke to you guys? That was boring. Can we do something better? You guys want something better, right? Yeah. You deserve better.
Relax, that balloon was just filled with air, just like you blew it up yourself.
Fine. This next balloon better be amazing, right, Kevin? Wow the audience, yeah? Or else someone's getting turned into a frog. I'm turning you into a frog. I've been waiting to do that all day. Once again, everyone, cover your ears. Awesome. Ignite the balloon! Yeah. And that's what I'm talking about. That was fantastic. Bring it up!
So that balloon was filled with propane, which is very similar to methane and is used in special effects to produce well-controlled and spectacular fires.
You ready? Cover your ears. This one's gonna be loud. Ignite it! I'm glad you guys like that. I gave that one an extra dose of magic. It was very big. Thank you.
Yep.
I'd like to see one of you try to explain that, other than arcane excellency.
I can try to explain it. That balloon was filled with hydrogen gas, which combusts very rapidly. And even better, when hydrogen burns, it only produces water, unlike other fuels like methane and propane, which produces carbon dioxide or CO2.
So chemists are really interested in finding ways to use hydrogen as a safe, clean fuel source. It's one of the many ways that chemistry has been contributing to green energy.
This stuff is really cool. Are you two hiring? Like, can I talk to you after the show?
After the show. After the show.
Okay.
What? Unbelievable. You think green energy is impressive? You guys think green energy is impressive like her? Not the reaction I was going for, but you know, whatever, I'll do my job. You want green energy so bad, I'll give you green energy. For this next trick, I'm gonna need absolute silence and absolute darkness. Just say about absolute silence.
Quack, you know you don't need to do that. flask and shh.
No, really, it's...
What did I just say? And now I give you green energy. Revel in my arcane excellency.
As I was saying, that flask has a boron-containing molecule inside.
Boron is element number 5 on the periodic table, and when you burn it, it burns bright green.
I think this was one of my favorite tricks so far. What other tricks do you guys have?
Allow me to show you. We will now turn water into Coke. Please welcome my assistants.
Again with the line stealing? I don't even sound like that. Was that a good impression of me? What is with this? Again, not the reaction I wanted. Hi, you guys. Alright, this trick is only going to require one magical ingredient. Sugar. Yeah. Add the sugar. Yeah. Add the sugar, please. I would do more there. You sure you're at sugar, right? I consulted the magic book. Forget this one. That's right. I think I need to add some spice. I lied about one ingredient. Add spice, please. Surely it will work. Just give me a minute. Okay, I'm clearly missing something. Oh my god, that's right. Add everything nice.
Maybe this is why he's retiring.
Watch yourself.
I can definitely see why.
Watch yourself. Okay. Maybe it was in the spell. Okay. Apprentice, this is your time to shine. Repeat those ingredients to me.
See, I just...
Yeah, we don't need to anymore. I'm so amazing! Thank you! Clearly don't need you for this job anymore. Who wants to be my apprentice? I pay really well. I see you, I see her, I see that one up there.
Actually, wasn't magic. I actually know this one clock, and I'll tell you what happened. That was called an iodine clock, and the magic ingredients or chemical reactants were undergoing a really cool set of reactions. One of them was super slow, and even though it was happening, you couldn't see it, which is why the solution didn't change color. But once that ends, another one happens in the blink of an eye, and that's what caused the color to change. So your chanting didn't really do much, to be honest.
So that's exactly right, Anishka. And by the way, that isn't Coca-Cola in there, it's actually iodine. So you really don't want to drink that!
Whatever. Not bad for a girl with no talent.
Rude.
Now, all this talk about Coca-Cola sure is making us crave something sweet, yeah? Like maybe a gummy bear? Okay, cool. I'm not gonna keep myself.
Wait. You can't have food in a lab setting.
Whose magic show is this? I'll do what I want.
I'm gonna report you to the safety TAs.
Safety TAs have nothing on me. I'll turn them into frogs. Now, I am going to make these gummy bears disappear. Assistants right now are preparing the gummy bears chamber, as you can see. Heat it up. Burn it.
Let it burn.
Now, be amazed as I dazzle your senses with this mundane yet delectable snack. Hold on to your socks. Hold on to them. You're going to hold on to them. Feast your eyes on this intense display of radiance and luminosity as this gummy bear is placed into its chamber and magically disappears. loves that color? Wow, you should all love that color. That color's fantastic.
Pink is definitely my favorite color.
Poor gummy bear. But what happened in that experiment was the liquid in the test tube is molten potassium chloride, a powerful oxidizer which can react with the fuel to burn. Gummy bears are almost pure sugar. Isn't the best for you, but they also store a lot of chemical energy that can be released as smoke and flames, like we just saw.
Let's talk about chemical energy. How do you know so much about the science stuff?
I thought you read my resume when you hired me. I studied chemistry in college.
Okay.
Anushka, you're always welcome to work with us.
Stop cheering her future on. I need to retire. Cheer for me. Hey. Wow. I'll end this magic show right here. Now, we've seen explosions, we've seen fires, we've seen time-delayed chemical reaction. Who cares? So now, let's show you something new. Let's show you something you've not seen before. An explosion! Bring out the can!
Wait, didn't you already say explosions?
Who doesn't want more explosions? Does anyone not want more explosions? Oh, okay.
Okay, everyone. So this next part's gonna be really loud again. So cover your ears, please.
By my will, you will explode! Explode! Is this on? Explode? Interesting. Maybe I need to retire earlier. Thank you. I am going to talk.
In the beginning, the can was only filled with hydrogen, which is fuel. But there was no hydrogen in the can, so only the hydrogen there was no oxygen in the can, so only the hydrogen leaking out the top could burn.
Yeah, the hydrogen leaks out of the top of the can because it is lighter than air. There's also a hole on the side of the can that allows oxygen from the air to replace the hydrogen leaking out the top. When enough oxygen gets inside, all the hydrogen inside the can suddenly burns at once, making the explosion.
Are you sure that's not me? That seems very magical to me. I think that was all me.
No, I don't think so.
I think it was all me. You guys think it was all me? So beautiful now. Whatever. Bring out the next trick. So these white crucibles that my lovely assistants are bringing out here contain an ordinary white powder. But watch as it transforms as we add just a few drops of student tears and... You're not going to interrupt me and tell me that's not student tears?
I wouldn't even know where you got your hands on those, but why don't we just go ahead and see?
Actually, they are student tears. He had me collect them unpaid on finals week. Most of them are my own, but...
I had to get them some way.
Please tell me you're okay.
absolutely love this next one. It's concentrated sulfuric acid, which is one of the strongest acids that we use in most chemistry labs. Why don't we show this experiment again?
Sulfuric acid? How does that work? I thought like the powder burnt.
Anushka, do you want to explain this one?
Let's wash it first. So remember how the sugar in the gummy bear burned before? Yeah, that super cool reaction. This powder actually contains both sugar and potassium chloride, just like the gummy bear experiment. The sulfuric acid reacts with the sugar, which releases heat and melts the potassium chloride, and that causes the sugar to burn. Who wants to see it one more time? Yeah? Okay. This one's going to be really bright, so don't look directly at it.
Go ahead and give it the bombastic side eye.
I told you the colors would come back. And the reason for the colors is because each powder also contained a little bit of salt made from different metals, potassium, sodium, or strontium. And when those metals burn, they each give off unique, distinctive colors, and they're frequently used in the beautiful displays of fireworks.
And believe it or not, scientists use the unique colors of light that atoms and molecules absorb and emit, like fingerprints, to tell them apart. Did you know that helium got its name because scientists originally discovered it by looking at the sun? We found helium in the sun before we ever knew it was here on Earth.
He invented helium? Like Isaac Newton invented gravity when the apple fell?
Exactly.
Oh, okay. Amazing helium, y'all. Speaking of. No, these past few experiments have been really hot and really bright, right? So why don't we cool it down? Everybody loves this.
What you got there, Quark?
That over here is liquid nitrogen. It's extremely cold, we're gonna freeze everything. Right now, these assistants are going to pour it into the bowl potted plant.
Same difference.
The fire that once doth burn now be sequestered into a barren and cold fog by my command, fog.
So yeah, you're right. Liquid nitrogen, not fog. Nitrogen makes up almost 80% of the air we breathe, but when you cool it down enough, it becomes a liquid. It's insanely cold. It boils at negative 196 Celsius or negative 320 Fahrenheit. It's so cold that it turns water vapor in the air into fog.
Boiling? Nice try. That over there is cold. Cold things freeze, hot things boil.
Very, very cold indeed. Now, watch what happens to the flower our assistant is holding. In a moment.
I think we just witnessed rejection happen in real time. One of you care to explain?
So like most plants and animals, flowers are mostly made of water, which when frozen to solid ice can shatter.
Yep, precisely. But it's not just liquid water that changes under extreme temperatures. Watch what happens when our assistant puts this balloon filled with normal air into liquid nitrogen. Wait for
It
it.
disappears. Oh, honey, I shrunk the balloon.
Yeah, almost like magic.
boiling. I think.
When a gas is cold, it takes up less space. We say that the volume of the gas decreases.
Okay, so we've seen shattering, we've seen shrinking. What possibly could be left? Tieu-Bang tubing, which as you can see is very flexible if you want to give it a little bend. So now we're going to put that in the liquid nitrogen and it's going to get very, very cold. Any ideas on what you think might happen?
It's gonna break because it becomes more like a solid.
Solid guess. We're going to give it a minute in its little pot there and we'll prove whether or not you're right or wrong.
It's better be worth the wait. If he's not correct, I'm turning him into a frog. Be
Leave it
prepared.
alone. You'll be fine, I swear. Maybe.
While that's happening, I feel like you told me before that liquid nitrogen is boiling. Does that mean it's going away?
So that's a great question. It sure is. When we put something that's room temperature in there, the liquid nitrogen also warms up and starts to boil or turn into a gas. So here's a great way to see that. That bottle right now has just been filled with the liquid nitrogen. When it starts to boil, we'll have it return to room temperature and gas will escape the bottle. Go for it.
That's me internally every single day. So what happened if you were to close that bottle? Can we stop the liquid from boiling?
That's a really important point. This is a public service announcement. Never close a bottle of liquid nitrogen because as the gas warms up, it expands a lot. So check this out.
Varsity Blues! That was fun, wasn't it? You guys have fun? You guys like that? Am I better in your eyes now? Am I a good magician now? I heard a bit of, yeah, I'll take a comment. Yeah, thank you. Can we move on now, or am I missing some? The Tieu-Bang tubing, right? The Tieu-Bang tubing. Let's see if you're right. Let's hope you're right. Incoming frog spell. Oh, uh-oh. Try it one more time. Surely it will work. Alright. You were right about it freezing, so I'll let you pass this time. I love shattering. Alright, so we all love shattering things just as much as the next magician or person. But we said that there was no water in this, so why did it freeze and didn't shatter? I know I didn't cause that to happen. I wasn't even anywhere near it.
You're right, there's no water to freeze, but rubber does become extremely brittle when the temperature plummets, thus losing its flexibility, and well, it was supposed to shatter.
Interesting.
How about I've about had it with this job, so Lauren, Aaron, consider this as my interview. I'm gonna host this next experiment. Can you bring out the metal pan from boiling water? Quack, can you pour that liquid nitrogen into the metal pan?
Tell the audience to clap for you as a magician, but never mind. The audacity you have to be ordering me around. I do the ordering around here. Assistants! Assistants! Pour!
I'm very excited for
You
this.
know what, since you're so confident about all this, what's your plan here? What do you plan on doing?
So liquid nitrogen is super cold, and it boils really fast when you put something warm in it. So for this trick, the kettle of boiling water is going to be dumped into the liquid nitrogen. Everyone, cover your ears, please. figured that by putting in the boiling water, the liquid nitrogen would vaporize and create a huge cloud. So Lauren, Aaron, how's my candidacy looking?
Very promising. That was really cool. I'm proud of it.
You get an A+ for me, lab reports aside.
So yeah, Anushka, that was awesome. I think you've come up with the perfect finale for our show today.
Finale? See, even the audience questioned you. You guys think that was worthy of being a finale? No. The answer is no. Stop saying that. Stop going against me. No, I want our finale, our true finale, to be even bigger, even more spectacular. Actually, I have an idea. Come on.
Alright, I think this might just work. It's ambitious, but if we pull this off, it'll be amazing.
Oh, I totally agree. This is gonna be really cool. Now, everyone, remember how we said to never close off a bottle of liquid nitrogen?
Because when the liquid boils, the gas needs to escape, otherwise pressure builds up. Well, we're going to show you how that works. Now this is going to be quite loud, so we're going to need everybody to cover their ears.
The safety TAs are gonna hate this.
The safety TAs don't know what they don't have to know. Cover your ears. It's very important. You can get a ball. Everybody gets a ball. Now that's what I call going out with a bang. Thank you everyone for coming to 2023's